Welcome to Section 10.2, Part 1. This is the 96th session of the CISSP Exam Prep series. In this session, we'll start turning facility design into working controls. We'll answer several questions. How do we group physical security controls? What order should controls act in when someone tries to break in? How do you plan for equipment that will eventually fail? Why does the wiring closet deserve serious protection? What makes a server room different from an ordinary room? And how do badges and proximity devices actually decide who gets in? Why does this matter beyond the exam? Because these are the controls you specify, buy, and audit in real life. Imagine standing up a new branch office, a colocation cage, and a small clinic's records room. Each needs the right mix of policy, technology, and physical barriers, chosen on purpose. Get the mix right, and access stays controlled without slowing anyone down. Get it wrong, and you either leave doors open or grind daily work to a halt. So how do we group physical security controls into three familiar families? Administrative controls are the human and procedural side. Things like facility selection, site management, awareness training, and emergency procedures. Technical controls are the electronic layer, such as access systems, intrusion detection, cameras, environmental systems, and fire suppression. Physical controls are the tangible barriers, like fences, lighting, locks, and guards. Notice the label physical is a bit narrow, since real facility protection blends all three. Think of a vault. The rules for who may enter, the electronic lock, and the steel door itself each play a distinct part. What order should controls act in when someone tries to break in? There is a functional sequence worth memorizing: deter, deny, detect, delay, determine, and decide. First, you deter with visible boundaries that discourage the attempt. If that fails, you deny direct access, say with a locked vault door. If they get past that, you detect the intrusion with sensors. Then you delay them long enough for help to arrive, perhaps with a cable lock tethering the asset. Finally, staff determine what is actually happening and decide how to respond, whether that means detaining the intruder or preserving evidence. A cable lock will not stop a determined thief, but the obvious damage from cutting it makes the stolen device hard to sell. How do you plan for equipment that will eventually fail? By matching your preparation to how critical the asset is. For low-stakes gear, knowing where to buy a replacement within a couple of days may be enough. For critical systems, you keep spare parts on site, accepting that faster recovery costs more in storage and expertise. When on-site spares are not practical, you sign a service-level agreement with the vendor that pins down exactly how fast they will respond. You also plan around 3 lifetime numbers. Mean time to failure is how long a device typically lasts, so replace it before that point. Mean time to repair is how long a fix takes. And mean time between failures tracks the gap between repeated failures. Above all, always have a backup unit ready, because waiting for total failure before replacing anything is simply unacceptable. Why does the wiring closet deserve serious protection? Because it is the nervous system of the building's network. A cable plant is the whole web of cables and gear that forms the physical network, from the entrance facility where the provider's line arrives, through the equipment room, the backbone, the wiring closets, and the horizontal runs to each work area. To guard the cables themselves, a protected distribution system uses sealed conduits, tamper-evident connections, and regular inspections to deter, detect, and prevent compromise. These closets also often hold alarm panels, breakers, and camera feeds, so an intruder who reaches one could steal gear, cut lines, or plant a listening device. So lock it tight, keep it clean and clutter-free, never treat it as a storage room, log every entry, restrict keys to the administrator, and inspect it on a schedule. What makes a server room different from an ordinary room? It is built for the equipment, not for people. A server room is a restricted, enclosed space, often run lights out and kept cool, because comfort for workers is not the goal. It may include gas-based fire suppression and walls rated to resist fire for a set period. Place it at the core of the building, and avoid the ground floor, top floor, and basement, along with anywhere near water, gas, or sewage lines that could leak or flood. Some organizations run their own room, while others lease space from a colocation or cloud provider in single-tenant or shared arrangements. Either way, physical access is managed with layered technical controls, from smart cards and proximity readers to biometrics and intrusion detection tuned for people, not packets. How do badges actually decide who gets in? By carrying either identity, authentication, or both. A badge can be as plain as a name tag marking employee or visitor, or as capable as a smart card using multi-factor authentication. A smart card is a credit card-sized token with an embedded chip that can hold or even process data, and it represents something you have. Because a single factor is never enough, it is usually paired with a personal identification number, so a stolen card alone will not let someone impersonate you. A magnetic stripe card is weaker, since it only stores data and is easy to copy, so it should not stand alone in a secure setting. And remember the distinction. Used for identification, the badge is swiped and then a second factor is required. Used for authentication, the person presents an identity first and swipes the badge to prove it. When staff leave, collect and destroy their badges as part of offboarding. How do proximity devices decide who gets in? By quietly signaling to a nearby reader who the bearer is. The device is worn or carried, and when it passes the reader confirms identity and access rights. There are 3 flavors. A passive device has no electronics of its own, just a small magnet that alters the reader's electromagnetic field, much like the anti-theft tags on store merchandise. A field-powered device wakes up and draws its power from that same field, which is the everyday card you wave inches from a door. A transponder is self-powered and actively transmits its signal, either continuously or when you press a button, like a garage remote or a car key fob. A related feature, automatic request to exit, uses motion sensors or pressure mats to unlock a door automatically as someone approaches from inside, easing exits without weakening entry control. So let's bring it together. Physical security controls fall into administrative, technical, and physical families, and they should act in the order deter, deny, detect, delay, determine, and decide. You prepare for inevitable equipment failure with spares, vendor agreements, and lifetime metrics. You harden the wiring closet as the network's nervous system, and you build the server room for equipment at the building's core. And you control who enters using badges, smart cards, and proximity devices, always layering more than one factor. Master these building blocks, and the rest of your physical program clicks into place. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.